Today we're going to talk about how to find the domain range of a function as well as the intervals of increase and decrease. So at the conclusion of this video, there'll be a short practice. Let me know if you have any questions. Okay. So the first thing we're going to take a look at is the domain of a function. All right. And if you read the little paragraph at the top, the domain can be identified as a set of x values for which the graph exists. Again, we're talking about x values. Domain can be written with inequalities or interval notation. I'll show you what that looks like. And every domain starts with the smallest x value and ends with the largest x value. So I'll repeat that kind of as we go. But what I want to show you here is, okay, on this first graph, we want to identify the domain. The domain is going to be the set of x values for where our graph exists. Now, if you take a look at this graph, now we're going to approximate here, okay? This is going to be at about a negative 2.5, all right? So this graph exists between a negative 2.5 and 3. All right, all of our graph is in between those two values. So this is how we do it. If I wrote it in words, I would say that my graph is between the x values, negative 2.5 and a positive 3, right? But inequality notation allows us to write it a little quicker. And I use this less than or equal to symbol. And this is kind of how we write a between statement. So when I write it using inequality notation, if you see what I wrote there, it's saying that x is between negative 2.5 and 3. So that's how we do it with inequalities. Now, one thing to point out here, if you notice on my original graph, and I'll kind of highlight them here, I'll make them nice and big. So if you look at the graph, these were closed circles. When you have closed circles, that means it's inclusive, and we need to make sure our inequalities have equal to's. So notice I use less than and equal to symbols for each of my inequalities. Now, there's also something called interval notation, and when they are closed points, we're going to use something called a bracket. And we can go from a negative 2.5, excuse me, there we go, to 3 with a closed bracket. Again, we're using brackets because they are closed circles, okay? So if I keep going, and I'm just going to do the domain again. So if we look at this one, so we want to know what x values that this graph is between. All right. Now, if you take a look at this, I know that it's going to be between the x values, negative 3 and a positive 2. Now, however, this isn't descriptive enough because do you guys see how there's an open circle at 2? So I'm going to highlight that here. There's an open circle here. So the way that we write this is I'm going to say negative 3. And at the negative 3 was a closed circle. So that gets a less than or equal to x, which is less than or equal to. X is always in the middle. 2. Oh. Now, there's one thing that I want to change here. Now, because this was an open circle, I want to highlight this. It won't be less than or equal to. It will just be less than. Now, the reason being is because that point doesn't actually exist. We can't actually equal that point on our function. It's like it's removed. So in this case, we would not put an equal to on an open circle. Now, for interval notation, okay, using those brackets or parentheses, we could write it the same way. Okay, let me get my stylus to work here. I can say from negative 3 to 2, but I would not use a bracket on the 2. I would use a parentheses. Okay, open circles always give you a parentheses. A closed circle gives you a bracket. I'm going to say that a few times to help you remember. Okay, open circle is a parentheses. Closed circle is a bracket. All right, let's take a look at the last one for domain. So if you look on the left end is an arrow. So what that means is this keeps going forever. And the same thing on the right side. So this graph is not going to have an endpoint on the left or an endpoint on the right. So my domain is going to be all real numbers. It's going to reach all the way from negative infinity all the way to a positive infinity. So it's going to go all the way. Notice the negative values are on my left of the graph and the positive values are on the right of the graph. So my inequality notation looks like this. Now, infinity is more of an idea than a concrete value, so that we never put equal to's on infinity. And because we never put infinity or equal to's, they always get parentheses. Okay, so our domain is all real numbers. You can write it in inequality notation to go from negative infinity, less than x, less than infinity, or you can write it in interval notation with the parentheses. Okay. Now, I want you to pause. I want you to try to figure out what the domain of this function is. All right. So if you take a second, I want you to do the domain on your own. And I am going to write the answer. Let's see if you were right. So the domain for this function, now if you did inequality notation, there's a hole there, so there's no equal to, just less than x, which is less than or equal to 1. Now if you did interval notation, I would use a parentheses. Very important, attention to detail here, from -3 to 1. So one of those two would be accepted. Okay. Again, we're using x values. All right. All right, so we're going to switch over. Instead of domain, we're going to find the range. Now the range is the set of y values for which the graph exists. So when I ask for the range, I want you now to look at the y-axis, or the values, the highest point and the lowest point, the maximum and minimum, if you will, right? So I want to figure out where is the smallest value, right? Let's get my pen working here. Excuse me. Sorry, hitting buttons that I shouldn't be. All right, let's try that again. So if I do the range, the smallest value, the minimum y value that I'm going to be is -5, and that's a closed point. Now, a lot of people want to tell me they look at the endpoint here as the lowest value or the highest value, but that's not true. The highest value is at 4. And if it's not indicated, it's safe to assume that there is a point there. So my range is the y values between -5 and a +4. Okay, now with inequality notation, I would say -5 less than y. Notice I'm using y values, which is less than or equal to 4. Or in this case, I can do interval notation the same way. And because those are equal to, because those are closed points, I use brackets. Okay, so this is how I find the range. The smallest y value to the biggest y value. So let's take a look at the next one. Okay, if I take a look, the smallest y value is going to be at 2. Now this graph has an arrow on it. And because it has an arrow on it, I know it's going to keep going. it's going to keep going to the right, and it does go up on a slight angle. So it's going to go up and to the right. So there is no limit to how high this can get. So this would go from -2 all the way to infinity. So I'm going to say all the y values from -2 to infinity. Okay, so if I do inequality notation, you can say -2 is less than, now it is a closed circle, so equal to y, which is less than infinity. Again, you do not put an equal to on infinity, you can't actually equal infinity. So again, because this had an equal to, I know it's going to have a bracket, and infinity does not have an equal to, so it gets a parentheses. Okay. Let's take a look at the range of the next one. So the lowest that it goes. Now, if you look at the graph as a whole, this keeps going down. If you look at my little arrow here. So this keeps going down. And although there's a little high point over here, this arrow is going to, if I make that window bigger, if I were to zoom out on my calculator, you would see that this left end of my graph is going to keep going up and up and up and up and up, and it's going to be the highest place. And because there's no limit, my range would go from -infinity to a positive infinity. But we want to write that properly. We want to write that using inequality notation. So -infinity, which is less than y, which is less than a positive infinity. Okay? And then interval notation, I can say, again, parentheses for all of our infinities. That would be my interval notation. Okay? Last one. So I'm working from bottom to top. The lowest that this graph goes is at -3. The highest that this graph goes is a +3. So I know it's going to be all y values between -3 and +3. So my inequality notation is going to be from a -3, and that was an open circle. And then I'm going to say a y. As soon as my pen starts working here. There we go. And then at +3, we had a closed circle. So my interval notation is going to be parentheses, -3, comma, +3 with a bracket. Okay. So I'm going to pause. I want everybody to answer this question. What is the range of the following function? Okay. I want to know what the range of that function is. I'm going to pause. See if you can figure out that range. I'm going to go, the lowest value is actually at this little vertex. Again, the minimum value is going to go from 0 y all the way up to 4. So you can say from 0 to 4. Okay? So the lowest, the bottom of your graph, all the way to the top. All right, so we're going to switch over. Intervals of increase, decrease. Okay, so we're going to do one of these at a time. So what they are, we're going to talk about like a subset of the domain for which my graph is increasing. And because we're talking about domain, I want to make a point. We're using x values to indicate the location of where my graph is going up. All right, so I'm going to try and do this with my red pen here. Okay, and I have a point. So we always read a graph from left to right, and it goes up. And if you look here, this other area of my graph is where it goes up. Okay, so again, I want you guys to see this area goes up and this interval is going up. So the first interval is going to go from about a negative. Now you can either use intervals or inequalities. Let me change my pen width here. There we go. Okay, is going to go from a negative 2.5 roughly all the way to 2. Okay, now if you want to use any intervals, I would say from negative 2.5 to 2. Okay, now there is a second one, actually. I'm going to write that on the line down here. Negative 2.5 to 2. Now there's a second interval that I want you guys to write down. Okay, and it goes from the 0 all the way to 2. So then I can also say from 0 x to 2, or another interval from 0 to 2. So there are two places where this graph is increasing. Again, if you notice, I'm using x values, right? From negative 2.5 to 2. From 0 to 2, we're using the x values to determine the interval of increase. Okay, same thing here. Let's take a look. Okay, I'm going to highlight it with blue this time. If you look, we always read a graph from left to right. This graph is increasing in the beginning all the way to it hits that vertex. So if we take a look at this, my interval of increase is going to be from the x value of negative 3 all the way to 0. Okay, then it starts going down. That's decreasing. That will be next. So my interval of increase is going to be from negative 3 all the way to 0. Now, I understand it goes to a height of 4, but that's not how we indicate interval of increase, decrease. We use the x value of that point, okay? And it hits the y-axis. The x value of any point on the y-axis is 0. All right, let's take a look at this last one. Now, this graph starts decreasing, goes down, and then it's going to go up, and then it's going to go down, and then it's going to go up forever. Now, this graph should have arrows on it. So if I take a look at this, and I should probably use a different color other than blue. If you take a look, we have two intervals of increase. And I'm going to count here. So this was negative 1, negative 2, negative 3. This was at 0. And then 1, 2, 3, 4, right? Okay, so my interval of increase is going to go from negative 3 less than or equal to x, which is less than or equal to 0, because 0 is where it stops increasing. But then there's a second interval of increase that goes from 2 all the way. Oh, I put an equal to. It doesn't stop increasing. It goes forever. So in this case, it would go to infinity. So I would say from negative 3 with a bracket to 0, and then from 2 to infinity would be my intervals of increase and increase. So we're going to just keep going. We're going to do the same thing, but intervals of decrease here. So I want to look at when my graph goes down. So this graph might look familiar. This graph is going down on the right side. So from 0, from the x value, okay, we're always talking about x values, from 0 all the way until 2. Now you might notice that I did not put an equal to on the 2 because there's a hole there. So my interval notation would look something like this. it is decreasing from the x value of 0 all the way over to the x value of 2. Okay? Let's take a look at the next one. It is decreasing between that maximum and that minimum. This maximum is at 0, and this minimum also happens to have an x value of 2. So my interval of decrease would again be from 0 to 2, or from 0 to 2. Everywhere else is increasing. You always read a graph from left to right. If you notice, this is all going up, this is going up, this is the only part that's going down. Okay. Next, where is it going down? Well, I have a little maximum to a minimum. So from here to here, right? And then from here to here, so that's where it's decreasing. So there's going to be 2 intervals of decrease. So I'm going to say from -2 to 0. And I'm also going to say from +2 all the way to 3. And if I did that as intervals, again, on a test or quiz, you could write this any way, either using the inequalities or the intervals. I would take either one. Okay? All right, so what I want you to do is I want you to pause. I want you to tell me what are the intervals of increase. Start there. Which are the intervals of increase? And then tell me what are the intervals of decrease going to be. Okay? And then answer that question. At any point, feel free to rewind, ask for help, let me know whatever it is that you need. Okay?